for people to believe that the sun goes around the earth rather than the other way around?
Well, obviously, because it looks that way.
I see. And how would it look if the earth went around the sun?
Well, I suppose... Yes. I see what you mean.
Those were scenes from a movie called Wittgenstein. He died in 1952. Throat cancer. Okay. So we have 4 types of statements, which we label A, E, I, and O. If I were going to say this dish is red, and then is square. And I'm talking about a set of dishes. So I have a box of dishes. All the dishes are red, and all the dishes are square. So therefore, no, what I'm going to do is go, all the dishes are red, all the red things in the box are square. So therefore, all the dishes are square. Now I have an argument, right? So I want to say all of the dishes are red, all of the do it, it'll be easier. So all the dishes, you eat, right?
Yes.
It's irregular. So all dishes in the box are red. All of the red things are square. So therefore, all of the dishes are square. Right? So if I change this and I have, this is a middle term, this is my subject term, this is my predicate term. What I have is the order of a perfect argument. All of the middle term is predicate, all of the subject is middle, all of the subject is predicate. The middle term we call middle because it is literally in the middle between dish in the middle and then the predicate. Right? So middle term literally is in the middle. The subject term of the conclusion is the minor term of the argument, just because they felt like calling it that. There's like no reason for it. And this is the major term. Bless you. Again, just because, well, hey, that's what they wanted to do. So a argument of this form is called AAA figure 1. And actually has specific code name. Named Barbara. Hey, they were gonna let me jump to Barbara, weren't they? That's neat. So you see the title of this particular argument form is AAA1, codenamed Barbara, which notice you have the A here, the A here, the A here, and the other letters are basically all part of a code that tells you you don't have to do anything to this argument. It's arranged properly. But if I go and look at, say, another argument, like Celerent, for example, which notice has 3 statements. The first one is an E statement, then an A statement, and then an E statement, right? No reptiles have fur. All snakes are reptiles. Therefore, no snakes have fur. Exciting arguments, aren't they? No reptiles have fur. That's true. Because Aristotle went around and he looked, and there were no furry snakes. But his wife wanted one, so he invented that scarfy thing that's got fur on it. No, that's just a joke. He didn't do that. What are those called? Bolos? Or no?
Boas.
What are they called?
Boas. Boas.
Boas. Which sounds like snakes. But they're not, because they don't have furry snakes. It says so, right? All snakes are reptiles. Circles, right? Categories. No snakes have fur. QED, which means quod erat demonstrandum, which was to be demonstrated, right? So whenever you want to give somebody an argument and you want to act like you're from Boston, lean your head back, look down your nose at them, and if you can, and say QED, kind of a Bostonian accent, and you get that kind of air of snobbishness that you may or may not want. But I'm thinking William Buckley Jr., William F. Buckley Jr., if you're familiar with him. He was the quintessential conservative, intelligent person when I grew up. He was the person I wanted to grow up to be like. But, he died. So this is Celerent. Notice that you have the E, the A, and the E. But these other letters then are code for you have to rearrange things if you're going to get this argument to be the same as Barbara. Because Barbara is the divine argument. Doesn't get any better than that. Notice, because the circle's here to demonstrate how this argument works. You have the middle term set, the major term set, predicate, and the subject term set. They overlap in what's referred to as a Venn diagram, which Aristotle did not invent. John Vann, who was a Harvard mathematician, invented them. And by the way, the Harvard chapel, all the stained glass windows are Venn diagrams of arguments. That is so cool, right? So you can imagine different colors. So that's Celerent, another argument form. Darii is AII. So notice all rabbits have fur, that's an A statement. Some pets are rabbits, that's an I statement, right? Some pets have fur. All rabbits have fur, some pets are rabbits, so some pets have fur. These are deductive, valid arguments that are also true. Right? So these are, all the statements are true. Statements can be true or false. Arguments are valid or invalid. Is this fun? Could be boring. I should dance a little bit more. You'll notice Aristotle is way more boring than Plato, but he's also correct. So that's Furioque EIO1. The advantage of knowing these, by the way, and I'm not suggesting we would do that in this one class, but of course logic covers these, but you spend a third of the semester basically trying to get the system down. But the advantage of it is, of course, if you're writing a term paper or a thesis and you've got great research and you've got true statements and you put it all together and you present it and everyone says, wow, that's really interesting. Only one problem, it's an invalid argument. You don't want to do that because, of course, invalid arguments mean you fail miserably. Whereas, you know, if you're familiar with the valid argument forms, then you don't have to, you know, you can make sure that your argument that's embodying your thesis is essentially a valid argument and you're good. You're all set. So, no homework is fun. Some reading is homework, so some reading is not fun. Pretty cool? Boring? No one actually speaks like this, but you can analyze the arguments that people actually give. We're usually a little bit more verbose. We might not put them in the right arrangement. So if you're a logician and you're analyzing the person's argument, you have to actually translate it into the proper form, figure out what form the arrangement of the statements ought to be so that you get one of these forms.
Is that one considered a valid argument?
This is.
Even though the statements are subjective and therefore not factual?
Yeah, this is still valid, even if you disagree with the statements. Because validity is the shape of the argument, not the truth or falsehood of the statement. So I could have a valid argument, even though it's got false statements and a false conclusion. I could actually have these are premises. You have two premises and a conclusion. What's interesting is I can have a valid argument even though my premises are false. If you accept the premises are true, then you have to accept the conclusion as well. But you might not accept that the premises are true. But it's still a valid argument because of the shape of the argument, right? That if you accept these as true, then you have to accept this, right? If it's true that no homework is fun and some reading is homework, then it must also be true that some reading is not fun. The reason for the strength of that is because the argument form is valid. And you can see how that works out here. So if I'm looking at this Venn diagram here, and what they're showing you are the three separate statements diagrammed here. The way the Venn diagrams work, if you've had statistics, this is just the opposite to confuse you. You color in where the overlap of where you're saying there are members. So in this case, if I'm saying so my homework, wait a minute, where am I? Okay, so no homework is fun, right? So there's no members in here. And that's reflected in this big space here, right? My second premise, however, says some reading, which is here, is homework, right? So there are some members in here, should be an X, right? There's my X, right? So then my conclusion, some reading is not fun, and there it is. This is reading, it's not fun. So it's, if the statements are true, then the conclusion must also be true. So it's a valid argument form. All of these are in this whole page here. Should be 24 of them. there are, out of the 4 types of statements that you have, if I'm arranging arguments of 3 statements, I have 64 possible combinations of AAA, AEE, EEE, III, OOO, AII, AOI, etc., right? 64 possible combinations. And what I haven't shown you is that there are 4 different figures. So the figure I showed you was figure 1, where the middle term was in this shape. Figure 2, the middle term is in this shape. Figure 3, the middle term is on the left in both first places. And in figure 4, the middle term is upper right, lower left. So you have 4 figures. So 4 times 64, you have 256 possible argument forms. AAA1 is the best of all of them. And then we have things like EIO1, which is valid. It's the form, right? So the forms are valid. And if you have also true statements in them, then you have a sound argument. So a valid argument form, together with true premises, gives you the best of all possible kinds of arguments. It's called a sound argument. But you can have a valid argument even with premises that are false. I can have an invalid argument with statements that are true, and it's still invalid. So for example, if I have really weak argument, some mice are nice. Some nice things are people. So therefore, some people are nice. Wait, are mice. This is an invalid argument, but notice my first 2 premises are true, but notice my conclusion is false. Although I have seen some people who are mice in Disney World. They have mice heads, you know, you walk around with ears. So this is fun. And this is called, so there's altogether 24 of these arguments, A002, Picardo, OA03, AAI. It's interesting why some of them are valid. So that's Aristotle's system of syllogisms. It's called syllogisms because in a sense you're bringing the logic of the statements together, I guess, right? Syllogism. They're all of the form with 3 statements. You can't have 4 statements, 2 statements. That doesn't work. And you can have strings of these in lengthy arguments, and when you do, they're referred to as a a Sorites. The word also means the paradox of the heap. So, you know, if you have a pile of, I'll say I have sand. I put 1 grain of sand on the table. Do I have a pile yet? No. 2 grains? 3 grains? 4 grains? When does it become a pile? Anybody know? No, we don't. So eventually, though, it becomes a heap, but we don't know when. So it's a paradox. But it's also the same word that you use when you have like an argument. So I remember George Bush W. When he gave a State of the Union address. It was Barbara, 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 all the way down. The speechwriters had just loaded the whole speech with deductive Barbara, 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 all the way down. And I thought it was interesting because, of course, his mom's name is Barbara. So that was it's just one of those things. Barbara Bush. So that was. Sometimes I think things are funnier than everybody else does, I guess. But yes, so you can. So we have examples. And they can be much longer too. There's a book by Charles Dobson. Am I remembering his name right? His pen name was. He was the author of Alice in Wonderland. What the heck is his name? Anybody remember? If I remember the one, I can't remember the other. I know he's got two names. If I remember the one. Lewis Carroll. So Lewis Carroll. But Lewis Carroll's other name is Dodgson. So Charles Dodgson. He was also in the kiddie porn, just so you know. If you're checking out some of his books, be careful. Some of the books in the library have the pictures he took of the kids, Alice included. And he liked taking pictures of them in the nude. So, strictly speaking, while it wasn't pornography, child pornography then, it is now. So, that could be an issue now. But that was when photography was just being developed. Okay, so I've talked about the nature of the categories. You can, of course, take a look at how he describes them, the forms of speech. The man wins. I of course, picked red plastic square dishes, but you can pick any things in grammar when you're talking about it. So when one thing is predicated of another, so that's why we say subject is predicate. We're saying that the predicate is the second category. We're saying this is in that category. So you're affirming a relationship, denying a relationship with the predicate, including some members in a relationship with the predicate, and denying a relationship between some members with the predicate. So we're calling it predication in English. Nature of substance. What would be the contrary of any primary substance, such as the individual man or animal? It has none. Substance doesn't seem to admit of variation or degree. The most distinctive mark of substance appears to be that while remaining numerically one and the same, it is capable of admitting contrary qualities, like dry and wet, hot and cold, etc. quantity is either discrete or continuous. Including math, speech, etc. Interesting kind of book. On interpretation, we notice here too, we're talking about language, how language is used and so on, nouns, verbs, etc. A verb is that which, in addition to its proper meaning, carries with it the notion of time. So we have past, present, or future, or some other tense, right? So, every boring thing you could think of, he puts all into these books. And this is the other logic book. Talking about arguments, including, of course, the syllogisms, and so on. Physics is about nature. So if we're talking about some are in motion. There are some startling mistakes that Aristotle makes. He thought that in order for something to continue to move, it has to constantly be pushed. Well, that's wrong, because things have momentum. We know that. Why did he make such a mistake? Don't know. Took Galileo to figure out that Aristotle made a mistake like that. Another thing, he thought that when things fall, that they, regardless of their weight, or rather, like light things will fall slower. You know, so when you drop like a feather, that's pretty obvious, and a ball, the feather will take longer to fall than the ball. But he also thought that if you had like a big ball and a little ball, and you drop the two of them, that the big ball would get to the ground faster than the little one, because it was heavier, right? Everybody believed this, even though you would think that would be pretty darn easy to test. Who's the first one to famously test it? Galilei, in the Tower of Pisa, supposedly, right? You know, so it's like this, so you can, you know how he dropped a bunch of balls all at once, I guess, and everyone stood down at the bottom and went, yes, they all arrived at the same time, even though they were all different sizes. Proof, Aristotle was wrong. This was scary, because Aristotle was considered right by the church. So you ought not to prove something that the church believes is true.
In those days.
Especially then, yes, because remember, he got in trouble for other things. Pretty interesting. So Aristotle does make another famous one. I've not actually seen where it is in the text, but everyone complains that he thought women had fewer teeth than men, and he was married. So everyone wonders, couldn't he have counted his wife's teeth? You know, and I don't know. I don't know how that happened. Okay. But our second book that we're supposed to be looking at tonight is the Metaphysics. So famously, it starts, all men by nature desire to know. Wow. I have seen lots of different translations of that, but it all basically suggests that everyone is curious and wants to learn. And yeah, I've met some people that, you know, just really aren't too interested. But now this is like his history of metaphysics up to Aristotle. And what Aristotle's opinion is that Aristotle knows everything. And the history of Greek philosophy up to Aristotle has been a history of the fruition of knowledge with him. So it's like a history. So there's an evolution of knowledge, and he goes back and he looks at his predecessors, starting with the pre-Socratics, so the ones before Socrates, right? And he's this, and by the way, this is where all that stuff that I've talked about and the fragments, mostly, not all the fragments, there are some fragments that others have written down, but for the most part, it seems like Aristotle's the one that gives us what we know about the pre-Socratics, like Anaxagoras and so on, as we don't have other records of them. In fact, they might not have written. Some of them might not have written. Remember Eric Havelock's argument that it seems Plato is the first one to really put into prose this kind of philosophical work. So maybe what we have is Aristotle talking about oral traditions associated with the pre-Socratics and what they thought. But it's with Aristotle that we actually get this kind of history. And he starts talking about causes. And this is a rather odd way of talking about it. We don't usually talk about causes this way, but what did I do with all the magic markers?
Well, there's one on the floor.
That one's green. I don't like green, especially when I have the lights off, for the most part. So, what do we mean by causes? We have what? So, like the from what? Or which? From which? Yeah, let's use which. From which? To which? By which? Spelling which right. I don't want the kind that has the black hat. I want, this is an H, right, not IT. Correct. And for which? So, the for which is the telos, which is interesting because, of course, Aristotelos, so that's, as far as he's concerned, everything that we could possibly know stuff about will, again, just like the 10 categories, have these 4 causes, right? The one cause is the telos, or the purpose for something. Everything has a purpose. It's in what we'll eventually call the great chain of being. He does not, but it's referred to as the great chain of being by Frank Lovejoy, I think. Let me double check. I don't see it mentioning the name of the book where it was. By the way, Linnaeus is the one who gives us the genre, the families, right, today?
Yes.
Yes. Aristotle, of course, in inventing all this stuff, gives us a variation of that, but of course it's been refined by the others. So this picture looks good. Use that picture. Well, that was better where it was, but Oh, that's not good. But you can imagine, it was thought that there's a great chain of being. This is a medieval conception where you have God at the top. Aristotle gives us a prime mover. And the prime mover is the outer circle of the universe, which he thought of probably as like crystal spheres, or maybe not. I don't know what he thought they were. The medievals thought they were crystal spheres with light shining through the star. Well, they're actually at a lower level, but the outer sphere, which is turning, but nothing's turning it, makes it the prime mover. So it's moving without being moved by anything else. And as it's moving, then the inner sphere is moving, which would be the stars, I guess. So I forget what the order is, but they have, the stars that are, out there, fixed stars, I guess. Then there's the moving stars, which would be the planets, right? Yeah, and so there's different spheres depending on how many they knew about, and it obviously changed as they discovered more. But once you get down to the air, then the air moves because of the spheres outside that is moving, and the movement of the air then moves what's like the waves and the wind. We have the wind, so it moves us. So you've got everything all interconnected, and then when you get down to as far as the medievals were concerned, you had the God, then angels, and then men, and men are in between. Actually, this looks like they've got multiple layers of angels, right? The heavenly choirs, which those were the ones that were the planet pushers, right? So each of the choirs were responsible for one of the spheres. And by the way, they made music. So of course, yes, there's music of the spheres associated with that. If you listen real quietly, maybe you can hear it. No, I don't think so. All the way down to hell, I suppose, right? But so everything is interconnected, and so has a purpose. So everything, wherever it is there because it has a particular purpose. The eyes to see, the ears to hear. And by the way, if they don't hear very well, that's okay because eyes can't hear. No, I meant the ears. The ears. If the ears can't hear, that could have been funny, but everyone's exhausted. Sorry. No, but obviously your eyes are good ones if they can see well. If they don't see very well, then they're not satisfying their purpose very well. Right? But that's for which a thing is made. By which. How did it get made? Mom and Dad? Or a table, the carpenter made the table. What did the carpenter make the table with? His energy, his wisdom of knowing how to, because he's making it for a particular dining room where he wants it to match, the chairs that he made last year. Why they didn't ask for a table then, he doesn't know. But now he's making the table to match the chairs. So he's using his tools, his workshop, his energy, his skills, all that. So skills or whatever, that's by which, right? The materials. Well, the materials are the from which. So the wood of the table that he's transforming, right? And to which is the shape of the table. Right? So the from which is the stuff that's being transformed. The to which is the final shape of the changed item, right? The by which is how it gets transformed. And the for which is why it's being transformed. Right? The purpose of the house. So you could think of this as like a house. So each step of the way is they have their plans, right? Plans for the house, 4-bedroom house for a family out in Palmer or whatever, right? And so how are they doing it with construction company, all the equipment, all the men, materials that they're buying from China, all that stuff. The house is the final product, ready to move in. Just have to turn on the electricity. Oops, it catches fire. Not very good. All the materials from, did I say from China? Of course it's from China. And of course we're mad at China because they're polluting the world, worst pollution of any country. And by the way, we're buying everything they make, so.
Cheap labor.
But so basically these four causes are what enable anything to be understood as it's changing, right? So the four causes. Oh, and I should give you, okay, so the first one, let's see, which one do I want? So this one would be the form, the formal cause, or the form, or the idea, the shape of the thing. This would be the material cause. From which it is made. This is what's referred to as the efficient cause. And this one is the purpose. We also have the teleological argument. It's the argument from design. Teleological argument. So for example, if you argue that God must exist because he's the great architect that designed this incredible universe. Right? It's the argument from design with teleological. So, is this interesting or boring?
It's interesting.
Pardon?
It's interesting.
It's very important stuff because what happens then, of course, Aristotle eventually becomes the philosopher. And everyone, I said the church basically accepted his philosophy as the truth. And by the way, because it's true, it's also what the church requires you to believe. So if you don't believe in Aristotle's philosophy, you should be burned at the stake, right? So that's pretty important to know what Aristotle says. But by the way, Aristotle was wrong, as Galileo discovers. Not only Galileo, there's all sorts of other things that others discover that Aristotle got wrong. Aristotle thought you only had to check something 4 times and then you knew what it was. Today we know at least 5 times before you actually know. Depends really. And so his inductive methods were terrible. He thought you just had to see it 4 times and then you're done. And all of his arguments then are deductive. So once you've decided, okay, this is a particular kind of plant, all these plants are in this family, and all of the things in this family are in this genre, and whatever genus, and everything in this genus is, in this clan. I don't know what, et cetera, right? So that's how knowledge is built. It's basically like all the interrelationships, all the things that don't go, right? Categorical reasoning, right? So for him, deductive reasoning is really figuring out where something is in this great big collection of stuff that you already know. So you're done. All knowledge is collected, right? And so when the medievals are looking at this stuff, to know something, all you have to do is study what Aristotle said, and then you know everything. So there was no interest in new science. You see the problem, right? So when people started getting interested in things and thinking, oh, he's wrong about this, I better check. Maybe I can make gold out of lead, well, that sounded like a magician, and that's bad, we should kill those people. And they killed a lot of them, right? So that's why people like Sir Isaac Newton were so secretive about their experiments. They didn't want to, tell everybody. Famously, Faust, right? You heard the story of Faust? Yes, no, maybe so? Lots of versions of it, but basically Faust sells his soul to the devil for knowledge. Trouble is, so he has lots of fun, lots of success, gets all the women, catches all the diseases, but then the devil comes to take his soul, and he goes to hell, which is like the terrible payment. It just goes to show, don't disagree with Aristotle. Right? But as the Enlightenment kind of goes into the Romantic period, you get a different version of Faust, where Faust learns everything from the devil, he sells his soul to the devil. Then by the time the devil comes to collect, Faust has figured out a way to trick the devil out, and he gets away with it. So you see, he's outsmarted the devil. So that's, the Romantic view is that if you learn enough, you can outsmart the devil, right? Which is not Aristotle. So, I need another quiz question. Should I ask you to give me an example of Barbara, a deductive valid argument? AAA1? Would that be fun? It would be easy to figure out, right? And if you're wrong, that's okay. I'll just say, well, you were wrong. That was Celerant, but that's okay. Doesn't have to be an interesting argument. In fact, if it's AAA1, it won't be interesting because it'll be so repetitious. All noses are runny. All lips get the runs. No, that's, no, I better not do that. I'm getting it all screwed up. You have to have the middle term is the predicate term, and then you have to have the subject term is the middle term, and then the subject term is the predicate term. So, the second word has to be the final word. So, it's a different way of, like, I drew it this way. This is the middle term, and the middle term is the predicate, so therefore this is the predicate. But when you're diagramming arguments using John Van's method, what you do always is draw three circles. Either this way is the way they have it there. Sometimes you have this one on top, but this is the middle. This is the conclusion, so the argument goes this way, subject, predicate. The first statement is always this way. The second statement is always this way, which then leads you to the conclusion that goes that way. And you're showing that you have three sets of things, and you can say something about the relationship between these two sets, and then something between these two sets, it leaves you then with knowledge of the relationship between these two sums. Aristotle funked this up without the benefit of the Venn diagram, which is even more impressive, you know, because they were also doing math in their head with letters. You know, so alpha, and they didn't have plus. They didn't have this. So it's not like you could say alpha plus alpha equals beta. 1 plus 1 equals 2.
So he was the first one to figure out algebra?
No, algebra was the one that figured out algebra. Yes, yes, that's where that comes from. Algebra. It's not my fault. Well, no, that's not helping.
It corrected it.
Well, no, that's not. It's like 15 different names or something, that's somewhere. Completion or reunion of broken parts. But I've heard it was algebra or something.
Been there.
Oh well. Too much fun? Should we quit?